Hi everyone. Today we discuss about the topic binary code. What is binary code? Binary code is a pattern of zeros and one used to represent discrete information such as decimal digits, letters and symbols. Also colors. Binary codes change only the representation of information, not its actual meaning. Therefore, the bits stored in a computer may represent coded characters, instructions, images, or other information, not only binary numbers. The particular group of bits assigned to an item is called code word. For example, in 8421 BCD, take a decimal digit 6. It will be represented as 0110. Here 0110 is the code word representing decimal digit 6. An n binary code can produce up to 2 power n different combination. For example, consider a number of bit is 1 bit. Possible combination is 2 power n 2 power 1 is 2. And then consider a number of bit 2 bit. Number of possible combination is 2 power 2 is 4. For a 2-bit code, the possible combinations are 00, 01, 10, 11. Each element must be assigned a unique combination. Two elements cannot have a same binary code because it creates ambiguity. To represent m different elements, the minimum number of bits must be satisfied. 2 power n greater than or equal to m. For example, 10 decimal digits require at least 4 bits because 2 power 3 is 8. It is less than or equal to 10. So, we take it as 2 power 4 is 16. It is greater than or equal to 10. However, more bit than the minimum may also be used. For example, decimal digit can be represented using a 10-bit code, where each digit has one bit set to 1, all the other bits set to 0. And then classification of binary codes. The group of bits, also known as binary code, represent both numbers and letters of alphabet as well as special character and control function. They are classified as numeric and alphanumeric. Numeric codes are used to represent numbers. Alphanumeric codes are used to represent characters, alphabetic letters and numerals. Weighted codes. Weighted code is a binary code in which each bit position is assigned a fixed numerical weight. The value represented by a code word is found by adding the weights of all bit position containing 1. For a 4-bit code, A3, A2, A1, A0 with weight W3, W2, W1, W0. And then n must be W3 into A3 plus W2 into A2 plus W1 into A1 plus W0 into A0. Common weight code include 8421 BCD, 2421 code, 5211 code. The 8421 BCD and 6311 codes are examples of weighted code because the value of every decimal digit can be calculated using their assigned positional weight. Uh, Weighted code uses in representing decimal digits, converting between binary and decimal formation, that is nothing but decimal to BCD encoder, BC to decimal encoder, and then performing decimal arithmetic. Examples: BCD additions, BCD subtractions. And then application of weighted codes. Weighted codes are used in digital clocks and timers, calculators, 7-segment displacement. Next, non-weighted code. Non-weighted code, also called as unweighted code, is a binary code in which the bit position are not assigned fixed positional weight. Therefore, the represent value can be found by simply adding the weights corresponding to the bits that are 1. Each code word is interpreted according to a particular coding rule or a code table. Gray code is an unweighted non-arithmetic code because its bit positions have no specific numerical weights. Examples of non-weighted codes are gray code, XS3 code, 2 out of 5 code. Uses of non-weighted codes. Non-weighted codes are mainly used when a digital system requires a special property rather than easy arithmetic calculation. Used in reducing transition error, representing mechanical position, analog to digital conversion, and then application of non-weighted codes are used in industrial control system, rotatory encoders, and shaft position encoders. Next, refractive coders. Refractive code is a binary code in which the code word for the nines complement of the decimal digit is obtained by complementing every bit of the original code word. Reflective code is also called self-complementing code. Complementing means if the bit is 0, then it is 1. The bit is 1, then it will be a 0. For a decimal digits, the complementary pairs are if the decimal digit is 0, the ninth complement digit is 9. If the decimal digit is 1, then the ninth complement digit is 8. Code that a code is refractive when the code of 9 is the complement of the code for 0. The code for 8 is the complement of the code for 1. And then the code for 7 is the complement of code for 2 and so on. Example 2421 refractive code. 2421 refractive code. Example for the refractive or a self-complementing code include 2421 code, 5211 code, XS3 code, some negatively weighted decimal codes. But 8421 BCD code is not refractive because complementing its code word does not produce the code for the ninth complement digit. Refractive code uses in finding the ninth complement, decimal subtractions, and complement-based arithmetics, decimal code conversions, etc. And then advantage of refractive codes. It is easy nines complement generation and simpler subtraction hardware, fast operations, and reduced circuit complexity. And then refractive code used in decimal arithmetic circuits, digital calculators, decimal computers, financial and commercial data processing. And then next one is sequential code. Sequential code is a binary code in which each succeeding code word is numerically one binary value greater than the preceding code word. In simple term, when the representing decimal digit increase by 1, the binary value of its code word also increase by 1. For example, 8421 BCD code, XS3 code. The uses of sequential code representing ordered decimal digits, decimal countings, mathematical manipulatings, and then applications of sequential codes are digital clocks, electronic calculators, digital counters, 7-segment display system, etc. And then next one is alphanumeric code. Alphanumeric code is a binary code used to represent alphabetic characters such as A to Z and then decimal digit 0 to 9, punctuational marks, etc. In a simple term, alphanumeric codes allow digital system to represent and process textual information using combinations of zeros and ones. Example of alphanumeric codes are ASCII, extended ASCII, and then alphanumeric codes are used in representing text inside computers. For example, when a user type cat, each letter is stored using its corresponding character code and then used in data communications and then used in displaying characters, storing data, etc. Advantage of alphanumeric codes are standard representation of characters, easy storage and processing, reliable data communications, support both data and control informations. And then applications of alphanumeric codes are computers and laptops, keyboards, mobile phones. In mobile phones, alphanumeric codes are used in text message, contact names, emails, etc. And then next next classification is Unicode. Unicode is a universal character encoding standard that assigns a unique number, each code point to each character used in a world's written language. It represents letters from different language, decimal digits, punctuational mark, mathematical and technical symbols, currency symbols, emojis, control characters. Unicode uses a universal character set to assign every character a unique numeric values and names. It is designed for computer applications involving multilingual text, mathematical symbols, and technical characters. Unicode encoding formats are UTF-8, UTF-16, UTF-32, and then Unicodes are used in representing multilingual text. Unicode allows a single digital system to represent many languages such as English, Tamil, Hindi, Chinese, Malayalam, and then used in sorting text in computers. Unicode is used in program source code, etc. And then transmitting text, representing symbols, handling difference, and then application of Unicodes used in websites and internet applications, mobile phones, operating systems, etc. Cyclic code. Cyclic code is a binary code in which two successive code words differ in only one bit position. In a complete cyclic sequence, the last code word and the first code word also differ in only one bit. Cyclic code are also called unit distant code or a gray code. Example, 3-bit cyclic gray code. Why cyclic codes are needed? In ordinary binary, several bits may change when moving from one number to the next. For example, 7 is 0, 1, 1, 1. 8 is 1, 0, 0, 0. All 4 bits change. In actual hardware, these bits may not change at exactly the same. Temporarily intermediate value may appear and produce an incorrect reading. In a gray code, only one bit change between adjacent value. Therefore, transmission ambiguity is greatly reduced. And then uses of cyclic codes used in representing continuously changing positions, preventing transition error, encoding system stages, arranging K-maps. Advantage of cyclic codes are only one bit changes, reduce incorrect intermediate values, reduce ambiguities. Applications of cyclic codes used in industrial control systems, K-maps, sequential circuits, traffic light controllers. And then next classification is error detecting code. Error detecting code is a binary code that adds one or more extra bit called redundance bit or check bit to the original data so that the error occurring during data storage or transmission can be detected. A bit error occurs when 0 is 1, 1 is 0. Why error detecting codes are needed? During the data transmission or storage, binary values can change because of electrical noise, signal interference, weak communication signals. Error detection code helps the system recognize that the received data may not be corrected. Example of error detecting codes are parity code, cyclic redundance check, checksum, etc. The uses of error detecting codes are detecting transmission error, checking stored data, verifying downloaded files, protecting communication packets. And then advantage of error detecting codes are improves data reliability, detect errors automatically, prevent occupied data from being corrupted, prevent corrupted data from being accepted, simple implementations, etc. And then applications are error detecting codes are used in computer networks, internet communications, hard disk, SSDs, and memory cards. Next, error correcting code. An error correcting code is a binary code that adds several extra bits called redundance bit, check bit, or a parity bit to the original data so that the error occurring during storage or a transmission can be both detected and corrected automatically. Why error correction codes are needed? Error can occur because of electrical noise, signal interference, weak communication signals, hardware failures. Examples: BCH code, low density parity check code, error correcting code memory, etc. Uses of error correcting code used in correcting memory errors, correcting transmission errors, protecting stored files, and then improving system reliability. Advantages are automatic error corrections, no retransmission of correctable errors, improved data reliability, identify the error position, protect both data and parity bits, suitable for hardware implementations. And then applications are used in ECC computer memory. ECC means error correcting code. And then satellite, used in satellite and space communications, hard disk and solid state drives, mobiles and wireless communications. Thank you.